review sheet, section 2.1, part 2. Number 1, the sum of two numbers is 7. Let's pick x and 7 minus x. You can see that when you add those, you get 7. In part A, find a function f of x for the sum of the square of one number and 2 times the square of the other number in terms of one of the numbers x. Okay, so if we pick x and square it, that's one of the numbers squared, and then plus 2 times the square of the other, we can write 2 times 7 minus x squared, and we're finished. Part B, find a function g of x for the product of the two numbers in terms of one of the numbers x. Well, the product of x and 7 minus x is just x times 7 minus x. Okay, that's all we need to do on that one. On number 2, a piece of wire 10 inches long is cut into 2 pieces. One piece is bent into the shape of a square, and the second piece is bent into the shape of a circle. Find a function capital F of x, which is the sum of the areas of the square and the circle, where x is the length of one of the 2 pieces. Okay, so we have a piece of wire that is 10 inches in length, and I'll just say that that piece right there is x inches, and then this one is 10 minus x. Those two have to add up to 10. X plus 10 minus x is 10. So let's start with the circle. We'll take the piece that is x inches long and bend it into the shape of a circle. So that means the value of x is equal to the circumference of the circle, which is 2 times pi times the radius. We set that equal to x. We want to know what r is in terms of x. So here we just find that the radius is x divided by 2 pi. And so the area of a circle is pi times the radius squared. So the area of this circle is pi times its radius, x divided by 2 pi squared. And that's how we'll leave it for this part. For the other piece of the other wire that's 10 minus x inches in length, we're going to bend that into the shape of a square. A square, all 4 sides are equal, so that means if 10 minus x inches is the perimeter of the square, then each side is 10 minus x divided by 4. And then if we want to find the area of the square, we just square the length of one of the sides. Okay, so this represents the area of the square. This represents the area of the circle. This function, capital F of x, is the sum of the areas of the square and the circle. So the capital F of x, this area of the circle is 10 minus x all over 4 squared. That's the area of the square. We add that to the area of the circle, which is pi times x divided by 2 pi squared. Okay, we don't need to get any fancier than that. In the next problem, number 3, a square is inscribed inside of a circle and its radius is r. So pretend like that is a circle, and we'll inscribe a square. And it turns out that when you inscribe a square in a circle, the radius is half of the diagonal of the square, which means the length of this side right here is 2 times r. And so this is just a drawing that we're going to use for part A and part B. This one says find a function capital P of r for the perimeter of the square in terms of r. So let's just let each side of this square that's inscribed in the circle be x, and then the length of the hypotenuse is 2 times r. We're focusing on this right triangle, and we want to determine what the value of x is in terms of r. So we apply the Pythagorean Theorem to this right triangle. We square the length of the hypotenuse, so we square the term 2r, and then that's equal to the sum of the squares of the two other sides, so x squared plus x squared. And the goal here is to solve for x. So we have 4r squared equals 2x squared. Divide both sides by 2, we get 2r squared equals x squared. And then take the square root of both sides, so x in terms of r is the square root of 2 times r. Okay, in part A, find a function capital P of r for the perimeter of the square in terms of r. Well, the length of each side of that square is x, but in terms of r, it's the square root of 2 times r. So the perimeter is, in terms of r, is 4 times the square root of 2 times r. Find the area of that square in terms of r. Well, if each side is the square root of 2 times r, then the area is just one side squared. So when we square the square root of 2r, we can simplify this a little bit easily enough, and this becomes 2r to the second. Okay, finally in problem 4, let f of x be equal to the square root of x. We want to find a function capital A of b, which finds the area of a triangle whose corners, well, a better word would be vertices. The vertices of the triangle are at 0, 0, BC, and B0, where BC is on the graph of y equals f of x. Okay, well, if we sketch a graph, a rough graph of the f of x equals the square root of x function, it will look something like this. And we're going to construct a triangle. One of the vertexes is at 0, 0. A second one is at B0. So here's the value of B on the x-axis. This ordered pair is B0. And then we're told that the ordered pair BC is on the graph also. Okay, well, since BC is a point on the graph of f of x equals the square root of x, we can relabel the y-coordinate of this point, because this y-coordinate is just the square root of the x-coordinate. Okay, and what this tells us is we have a right triangle whose vertexes are at 0, 0, B0, and B square root of B, and we want to find a function that measures the area of that right triangle. Well, you'll remember that the area of a triangle is 1/2 base times the height, and so the base of this right triangle is length b, so the area is 1/2 the base, which is length b, times the height. The height of this right triangle is the square root of b. And we're finished. The area of that right triangle in terms of b is 1/2 b times the square root of b.